ever pondered the possibility of traveling through time to witness the past or foresee the future? This intriguing concept, known as time travel, has been a beacon of fascination for centuries. It has permeated our literature, our movies, our dreams. From the fantastical journeys of H.G. Wells' Time Machine to the interdimensional adventures in Doctor Who's TARDIS, time travel is an idea that refuses to be confined to the realm of fiction. But what does science have to say about it? Is time travel merely a figment of our collective imagination, or could it be a scientific possibility waiting to be unlocked? Theories abound, some suggesting that time is linear, others proposing its malleability. Could we one day bend time to our will, traversing the timeline as easily as we traverse a road? From H.G. Wells' Time Machine to Doctor Who's TARDIS, time travel has always stirred our imagination. But can it ever be more than just fiction? The realm of physics has some interesting theories that might say yes to time travel. Let's delve into the world of theoretical physics, where the concept of time travel is not only fascinating, but also has some scientific grounding. One of the most famous theories that give credence to time travel is Einstein's theory of relativity. This theory posits that space and time are not separate entities, but instead, they are interwoven into a four-dimensional fabric known as space-time. Imagine a tightrope walker moving along a wire. The wire is space-time, and the tightrope walker is us, moving in one direction, which we perceive as the flow of time. Now, let's add a twist to this. Einstein's theory also suggests that massive objects, like planets or stars, can distort this space-time fabric, causing it to curve. This is what we experience as gravity. But what if this distortion could be used to manipulate time? Well, theoretically it's possible. If you could create a tunnel through this fabric, a shortcut if you will, you could, in theory, travel from one point in space-time to another faster than light would in normal space. These tunnels are what we call wormholes. Wormholes are fascinating structures. They are bridges through space-time, potentially connecting different points in time and space. If we could find or create a stable wormhole, and if we could travel through it safely, then hypothetically, we could use it to travel in time. Of course, these are highly complex theories, and we're simplifying them a lot here. The mathematics and physics behind these ideas are incredibly intricate. But the bottom line is, according to these theories, time travel isn't entirely out of the question. It's just that we haven't figured out how to make it work yet. So, in theory, time travel could be possible. But what about the practicalities and paradoxes? Imagine going back in time and accidentally preventing your own birth, a classic time travel paradox. Now that's a brain teaser, isn't it? This is known as the grandfather paradox. It's a hypothetical scenario where you travel back in time and somehow cause your grandfather to die before he has any children. Now, if your grandfather never had children, your parent and consequently you could never have been born. But if you were never born, then how could you have traveled back in time to cause this disruption? Puzzling, right? But wait, there's more. Let's dive into another paradox, known as the bootstrap paradox. It's a scenario where an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop in which the item no longer has a discernible point of origin and is said to be uncaused or self-created. Imagine, for instance, a book. You receive a book from a mysterious stranger who then disappears into thin air. This book inspires you to become a writer. Years later, you find a time machine and decide to give your younger self the book that started it all. So, you become the mysterious stranger, giving the book to your younger self. Now the question is, who wrote the book in the first place? It seems to have no beginning or end, existing in a continuous closed loop. This, my friends, is the bootstrap paradox. These paradoxes are mind-bending, aren't they? They underline the complexities and contradictions that arise when we contemplate the concept of time travel. But they also make the idea all the more intriguing. It's like a riddle wrapped in a mystery inside an enigma. So while we would all love to hop into a time machine and take a trip to the past or future, these paradoxes serve as speed bumps on our journey, forcing us to ponder the implications and consequences of our time-hopping adventures. Paradoxes surely add a twist to the tale of time travel, don't they? Quantum physics, the rulebook of particles, has its own take on time travel. This fascinating world of the tiny, invisible, and mind-bendingly strange is where the rules of our everyday reality become blurred. Here, a particle can be in two places at once, thanks to a phenomenon known as quantum superposition. But how does this relate to time travel? Well, imagine a particle that exists not just in different places at the same time, but in different times at the same time. Sounds strange? Welcome to the quantum realm. This is not just a theoretical concept, but has been experimentally demonstrated with photons, the elementary particles of light. In one famous experiment, scientists were able to make a photon exist in three states at the same time: the past, the present, and the future. This was done by sending the photon through a series of beam splitters and mirrors in such a way that it could not be determined which path the photon took, creating a superposition of states. In essence, the photon traveled back in time, existed in the present, and also jumped to the future, all at the same time. This is what we call quantum time travel. But before you get excited about the prospect of quantum time machines, remember that we are talking about a single particle of light. Translating these quantum phenomena to the macroscopic world of humans and time machines is a whole different ballgame. The scale is unimaginably vast, and the physics becomes incredibly complex. Moreover, we still don't fully understand the quantum realm. It's like a puzzle with missing pieces. We can see the general picture, but the details are still fuzzy. And until we can see the full picture, our dreams of time travel remain just that: dreams. While quantum physics might provide a ray of hope, we are still far from hopping into a time machine. So how close are we really to packing our bags for a trip to the past or future? Let's dig into the nuts and bolts of what it would take to actually achieve time travel, according to our current understanding. The technological and energy requirements are, to put it mildly, formidable. For instance, based on Einstein's theory of relativity, to bend the fabric of space-time, we would need to harness the energy of a star. Now, that's not exactly something we can plug into a wall socket. In addition, the technology to control such vast amounts of energy in a precise and safe manner is far beyond our current capabilities. It's akin to trying to build a rocket ship with a pocket knife and duct tape. We're just not there yet. Then we have the issue of the time machine itself. Theoretical models suggest that a time machine would need to be a closed time-like curve, a sort of cosmic loop that brings you back to your starting point in time. But constructing such a curve would require materials with negative energy density, something that is not known to exist in our universe. Furthermore, there's the practical issue of survival. If we could somehow manage to create a wormhole for time travel, would a human being be able to survive the journey? The extreme forces and conditions involved could prove fatal. Lastly, there's the matter of paradoxes. If you were to travel back in time and change something, how would that affect the present? The potential for timeline-altering consequences adds yet another layer of complexity to the already daunting challenge of time travel. In conclusion, while time travel is a captivating idea that has inspired countless stories and scientific theories, the reality of it is still firmly in the realm of science fiction. The obstacles to achieving it are immense and, at present, insurmountable. Time travel for now remains a fascinating concept that continues to inspire scientists and dreamers alike. Time travel, once a figment of fiction, might have a basis in our physical laws. It's a tantalizing concept, isn't it? A journey not just through space, but also through time. In our exploration, we've delved into the theoretical foundations, pondered upon the paradoxes, and ventured into the quantum realm. Theoretical physics, with its fascinating ideas like wormholes and black holes, provides a glimmer of possibility for time travel. Yet it's not without its paradoxes, those mind-bending situations that seem to defy logic. Moving on to the quantum world, we've seen how time travel might be possible on a tiny scale, though translating this to our macro world is a challenge of Herculean proportions. The reality? Time travel remains an elusive dream. The practical challenges are immense, and the answers are still out of reach. But remember, science never stops probing the unknown. Whether we ever achieve time travel or not, the journey of exploring its possibility is itself an exciting voyage into the unknown.